All right, we have two more examples from 7.3, and then we are going to start digging into 7.4 today. Your 7.3 homework is due tonight. And 7.4 is going to build off of what we've learned in 7.3. How can I use the information that they have given me to answer parts A and B up here? Yes, ma'am.
I was going to say, if it's acute angle, it's going to be in quadrant 1.
You're absolutely correct. If they are acute angles, then they're in quadrant 1. Thank you, Luca. For part A, I want the sine value of alpha plus beta. So what formula would I need to apply then? Sine. What's it look like written out?
Sine, beta, cosine. What's that again?
This first guy is an alpha, and this is a beta.
And then sine alpha, cosine beta, plus sine beta, cosine alpha.
Yes. I want to evaluate this for exact values. Do I know what the exact value for the sine of alpha is? Do I have the ability to find it? Yes. Okay, so let's do that. Cosine is what over what? I'm thinking x, y, and r. X over r. So I've got x squared plus y squared equals r squared. So 4 squared plus y squared equals 5 squared. 16 plus y squared equals 25. So y squared is equal to what? Y squared would be 9, which means y is what? Plus or minus 3. Do I want the plus or do I want the minus? Plus for this one because why? I'm in quadrant 1. So we're going to go with the positive 3. So now I know the sine of alpha would be what? 3 over 5. So that's what I can substitute in for sine alpha. Do I have an exact value for cosine beta?
Yeah, 15.
If it was on my unit circle, yes. I do not have an exact value for cosine beta. Do I have the ability to find it? Yes. Tangent is sine over cosine, and so when I'm talking x, y, and r, it is y over x. So I just need my r value. I know part of the cosine value is going to be 15, but I don't know it's 15 over what. So x squared plus y squared equals r squared. 15 squared. I don't know what that little mark is there by the 15. Oh, it's a comma. I was like, why does that have like a minutes mark? It's a comma to separate the sentence, but that's very weird placement. 15 squared plus 8 squared equals r squared. What is 15 squared? 225. 8 squared is 64. 225 plus 64. 289 equals r squared. So r is 17. Do I have to do the plus and minus on an r? No, because the radius is always positive. Radius is always positive. So what is the cosine for beta? (15/17). So we're going to use that. Plus, do I know the sine of beta? What is my sine value for beta? 8/17. And do I know cosine for alpha? 4/5. That was one of the ones that they just gave me. So now I need to multiply this together. What is 5 times 17? Because that's going to be my denominator. Is that 85? So 45/85 plus 32/85. So what, 77/85? So far, so good? Hopefully the second part of this problem will be easier. How do I find cosine for alpha plus beta?
The equation up there.
The equation up there, yes. Which is what? Cosine, cosine. So cosine alpha times cosine beta. What operator? Minus. Sine alpha, sine beta. What are the cosine values for alpha and beta? Four over 5 and 15/17. So that whole thing together there is going to evaluate to be what, 60/85? Please check my multiplication. I did it in my head. I'm going to bring down my operator. Is what?
Oh, no, I'm just thinking out loud.
Got it. What is sine alpha? 3/5. And sine beta? 8/17. So I get 24/85, which gives me what? 36/85. All right, so I found sine of alpha plus beta. I found cosine of alpha plus beta. I now have enough information to know what quadrant alpha plus beta is in. Did my sine value come out to be positive or negative? Positive. So sine, I need a little bit more room for this. Sine of my angle is positive. What about cosine? Also positive. Cosine of alpha plus beta is positive. Where's the only quadrant where sine and cosine are both positive values? First quadrant. I can't just get that information from up here, because if this was my angle alpha, and this was my angle beta, if I added those two together, it's possible that it pushes me into the second quadrant. Does that make sense? Did this one actually push me into the second quadrant? No. Let me draw an example of what I'm talking about here. So here's alpha, and then if I put beta on top of it, this distance right here would be that angle beta. That's what it means when I'm adding those two together. Does that make sense? Do you guys see how if they were large enough acute angles, I could add them together and get something bigger than 90? Okay. Yes, ma'am. Absolutely. Bathroom pass is right there. You're welcome. I'm going to put up the very last example from 7.3. It's exactly like this. This time, though, I have thrown in a little bit as far as we're not both angles in quad 1. It's telling us that alpha is in quad 3 and beta is in quad 1. I want you guys to do parts A and B on your own. You're welcome to work with a partner or talk to somebody near you as you work through this, but I want you guys to do this on your own before we go through it together. And if you think you can do part C as well, go for it. But I want you to focus on parts A and B. I'm going to give about 5 minutes for this. All right. So I'm going to need sine and cosine for alpha and sine and cosine for beta. I have sine for alpha. What is cosine alpha? You said negative 3 over 5. How did you know it was negative? Because it's in quad 3. All right, so we're going to use that. And then I have secant of beta. How do I use that information to find sine and cosine for beta? Yes, secant is r over x. So from that, I can tell what? What can I tell without having to do Pythagorean theorem at all? Cosine. Cosine of beta would be what? 3/5. What is sine of beta? 4/5. Positive or negative? Why? Because it's in quadrant 1. Perfect. All right, so now I need sine alpha, cosine beta. We said that sine alpha was negative 4/5. They gave us that one. Cosine beta, 3/5. What operator do I need? Addition. And then I need sine of beta, cosine of alpha. What is our sine of beta? Sine of beta is 4/5. Positive, yep. Cosine of alpha? Negative 3/5. So I end up with negative 12 over 25 plus negative 12 over 25, which gives me what? Negative 24 over 25. That is the sine of alpha plus beta. So what do you know right now as far as possible quadrants for the angle alpha plus beta? It can't be where or where. Can't be first quadrant. Can't be second quadrant because my sign is negative. So it's either third or fourth quadrant. Cosine of alpha plus beta. So I need cosine of alpha, cosine of beta. So cosine alpha, negative 3 over 5 times cosine beta, which is just 3 over 5, right? What operator do I need? Subtraction. And then we have sine of alpha times sine of beta. Sine of alpha was negative 4/5. Sine of beta was positive 4/5. So I end up with negative 9 over 25 minus negative 16 over 25. Well, I know I'm over 25. What do I get? 7 over 25. So the cosine of alpha plus beta came out to be what type of number? Positive. So what quad are we in? Fourth quadrant. Yep. Cosine that goes with your x values is positive. That means I have to be somewhere on the right-hand side of the y-axis. Since my y, my sign is negative, I have to be down in quad 4. Do you guys have any questions for me about anything in 7.3 before we start 7.4? Yes, sir.
Negative 24 over 25, is that like a degree or like, I know it's sine of x, or I mean beta, whatever. But like, what's that number?
That number is describing the ratio of the vertical height to the radius for angle alpha plus beta. Do you remember in geometry, and we even did it in here, where we just like drew the triangles and we would have our alpha? So what this is saying is that for this particular angle alpha, this distance is negative 24, which means technically my triangle needs to be flipped the other way. And this is 25. It's describing ratios for me. But it's an actual, it's a value. It's not, I guess if you wanted to put a variable to it, it's what happens when I apply the sine function to this angle alpha plus beta. I don't know what that angle is, but I do know it's in quad 4. Does that help a little bit? Okay. All right. 7.4. 7.4 is the multiple angle formulas. Which in a very general way, we've kind of talked about already. If I'm adding two angles together, that's multiple angles, right? What about if I take a single angle and I double it? That's the first thing that we're going to be touching on with our multiple angle formulas. So far, so good? Cool. I want to talk about our double angle formulas. So like sine of, I'm going to use u as my variable. Sine of 2u. We're going to figure out what this formula is. This would be the same as sine of u plus u, right? Because u plus u would give me 2u. Can we take one of the formulas that we were just using in 7.3 and apply it here? What would it look like? Sine u cosine u. And then what?
Plus sine.
Plus sine. Griffin, what did you say I want to use here?
Plus sine u times cosine.
Plus sine u times cosine u. Because my two angles, alpha and beta, in this case, are the exact same angle. Can I simplify that at all? If u plus u gives me 2u, 2 sine u cosine u. That is our double angle formula for sine. It's 2 times the addition formula for sine. Well, we have the addition formula for sine, and we could combine it together because my two angles were the same. Could I do the same type of thing for tangent? Tell me how I can rewrite 2u. Yep. Tangent, parentheses, u plus u. All right, so now I want to look at my tangent formula, and I want to apply that.
Tan u plus tan u.
Tan u plus tan u
Over 1 minus tan u times
over 1 minus tan u. Can I simplify that numerator at all? 2 tan u over, can I simplify the denominator at all?
Oh, no.
1 minus, what'd you say, Amaya? Tan squared u, because it's tan times tan. Beautiful. We've just derived 2 of our double angle formulas. Let's do the last one. Let's do cosine. Cosine of 2u. I want to use my addition formula to help me with this, so I'm going to rewrite that as cosine of u plus u. What's this going to look like? Cosine u minus sine u. Can I clean that up at all? Cosine squared u minus sine squared u. I feel like we could write some variations of this one. Don't we know something that could replace cosine squared? Can I do a Pythagorean replacement? What could I put in the place of cosine squared? 1 minus sine squared. And then bring down the other minus sine squared. So if I did that substitution, what would this simplified variation look like? 1 minus 2 sine squared u. So there's another cosine double angle. This is cosine of 2u. We've got this one. We've got this. Could I do this same type of thinking, but where I replace sine squared? What could I replace sine squared with? 1 minus cosine squared. So cosine squared u minus, and then I can put in 1 minus cosine squared u. I have to remember my distributive property here. What happens when I distribute the subtraction to that cosine squared u inside the parentheses? Yeah, it's going to be minus 1 plus cosine squared u. This is the last one for cosine. So how would that simplify then? 2 cosine squared u minus 1. So we have lots of variations of the double angle formula for cosine. Tangent and sine, there's just one. Cosine, because we had that sine squared and cosine squared, we could use some Pythagorean substitutions there. These are formulas that you will need to know, but they are all based on things that we've been practicing. You guys can recreate these formulas if you don't remember them, memorize them fully. I want to do just a couple examples with this, and then we will call it a week. The very first screen? I have all of these same ones posted on the next screen with the example. You good, Tommy?
Yeah, I'm good.
Okay. All right, so I have all of them posted right up here in the corner, since we just derived them and we're just now getting used to using them. I want to find the exact value. What kinds of information do I have to work with? What have they given me? They gave me secant. How can I use secant if I'm trying to find sine of 2x? Yes, secant is r over x. So I know my cosine then for sure, right? Cosine of x would be what? Negative 5 over 13. I can use Pythagorean theorem so that I can find sine. So I have negative 5 squared plus y squared equals 13 squared. So 25 plus y squared equals 169. Y squared is 144. Are you guys starting to notice some of these numbers that keep showing up in our triangles? They're called Pythagorean triples, ones that make nice whole number triangles, like our 3, 4, 5s. This is another one. Yeah, 5, 12, 13 is another Pythagorean triple. So y is equal to what? Plus or minus 12. Do I want positive 12 or negative 12? Did they give me enough information that I can make a decision on that? Yes. They told me right here what? It's in the second quadrant. So do I want the positive 12 or the negative 12? Second quadrant, my y values are positive. So what is the sine value for x then? Everybody's being so quiet. 12 over 13. Okay, so I've got those pieces. What is the formula that I need to use for sine of 2x? first one. So this is going to be 2 sine x cosine x. So 2 times sine of x, which is 12 over 13, times cosine of x, which was negative 5 over 13, sine of 2x would come out to be, will I have a fraction? Yep. What's the denominator? 169, because I'm multiplying those two 13s together. Will it be a positive fraction or a negative fraction? Negative. 120. Can I reduce that fraction at all? It is negative. I had the negative out in front and it was hard to see, so I moved it up to the numerator. What's the only thing that will reduce with the denominator? It's the only thing that goes into 169. 13. Does 13 go into 120? Then it's fully reduced. All right. Last one. Let's do one more. We'll be done with the week.
How'd you get the 2 sine x cosine?
What do you mean? This part right here?
Yeah.
That we derived on the previous screen. It's coming from my addition formula. Do you remember when we rewrote sine of 2x as sine of x plus x?
Yeah, I got you.
Yep. All right. Last example for the week. We're going to do number 2. We'll pick up with number 3 on Monday. What quadrant am I in? Second quadrant? First quadrant? How do we know? Yep, greater than 0, less than 2 pi. So we're in quad 1. And I want to find cosine of 2 theta. We've got 3 different variations for cosine of 2 theta. If I want to do the least amount of work on this, which it's Friday, so I do, which of those 3 variations would be better for me to use? The one that just has sine, right? Why? Because they gave me sine. I don't have to draw my triangle. I don't have to do Pythagorean theorem because this version of the cosine formula only uses sine. So I'm going to be lazy. We're going to do cosine of 2 theta is equal to 1 minus 2 sine squared theta. Sine theta is 1/4, and I need to square that. What's 1/4 squared? 1/16. So what's 2 times 1/16? 1/8. 1 minus 1/8? 7/8. So cosine of 2 theta is equal to 7/8. Let's call it a week right there.